In today's lecture, we'll develop the same concepts that we have learned till yesterday and we'll enhance our problem solving skills. So, we'll start with the problems that we left in the last lecture and then we'll learn one technique of drawing graphs and then again using those techniques we'll draw some graphs and solve some questions. Okay. So, today is full of problem solving. Let's proceed. So, there is a question here, find the area bounded by these two curves. So, here only two curves are given and it is clearly mentioned in the question that area is bounded, which means area must be enclosed by these two diagrams or it must be asymptotically bounded, one of them must be true. Because these two curves are parabolas, there is no chance for asymptotes here, so area must be enclosed. Now, if we check the graphs, the first function is a parabola which is horizontal parabola like this, having x axis as the axis of the parabola and y axis will be the tangent at vertex. And the second parabola is basically the vertical parabola. So, which means we will get a graph like this. And what is the area enclosed? Now, we can see that there is an enclosed area. So, this is the area enclosed between these two curves. Now, what are the steps to proceed? We need to find the limits also. Before we go for the integration, we have to find limits. And one point is very clear here, which is 0, 0. That is one point of intersection. Other point of intersection needs to be calculated. That will calculate. So, here if we go for the idea of area formed with x axis or area formed with y axis, either way we can get the area. So, because we are mostly comfortable with area formed with x axis, I am going with area with x axis. So, what is the above function? Above function is this y square equal to 4ax function and below function is this x square equal to 4by. So, I need to solve for the points of intersection. So, I will substitute either for x or for y. So, here I will substitute for y. So, what do we get? X square by 4b whole square must be equal to 4a into x. Now, when we simplify this and factorize, we will get one factor which is x as common and the other will be x cube minus 64ab square. This is equal to 0. So, there are two roots here. One is x equal to 0, the other is x cube must be equal to 64ab square. Now, from here if I solve for x, I will get x as 4ab square whole raised to 1 by 3. Okay. So, we got the limits. Let me just name this limit as p and I am going to integrate this from 0 to p. Okay. So, the limits are basically 0 and p. Remember that whenever we integrate, limits vary on x axis only, dx is varying only on x axis. Okay. So, now what will be the area? Area can be written as integral of 0 to p. What is the first function? This is the above function. So, for this if I write y in terms of x, it must be root of 4a into root x minus the other function is x square by 4b and we have to just integrate this. Okay. So, integral is very simple. So, I will straight away perform the integration. So, it becomes 2 root a into x root x by 3 by 2, limits going from 0 to p and minus 1 by 4b into x cube by 3, limits going from 0 to p. Now, when I simplify this, I will get 4 root a by 3 and what is the value of x here? Basically, this is root x whole cube. Now, what is the value of p here? It is basically 4 into ab square whole raised to 1 by 3. So, when I put it, I will get 4 into ab square, this is the cube root here and whole raised to 3. So, this needs to be simplified, right. Okay. So, there is also one root here. So, there must be 3 by 2 here. Okay. Now further minus 1 by 4b into 1 by 3 into x cube, that means it is the p cube. So it becomes 4 into cube root of ab square whole cube. Now we just have to simplify it. So let us simplify. Here we have 4 root a by 3 and here we have 2 cube which is 8, and here when 3 gets cancelled we will get root a into b, and further here also 1 by 12b, and here we will get 4 cube and here we will get ab square. So 1b is getting cancelled and 1 4 is getting cancelled. So we will be left with 4 square here. So what else is given? What else is there? So everything is fine till now. So here we are getting 32 AB by 3 minus 16 AB by 3. So the answer has to be 16 AB by 3. Okay. So check if I have done any simple silly mistake of calculation or something. Okay. But this way we can calculate the area. Okay. Come on, quickly make a note of this. Okay. Now we will move on to the next question. So here question is, find the area bounded by these two curves. So how do we do that? For that we need to first draw the graphs. So here it is not exactly log function, it is log of x plus e. That means when something is added to x, graph must shift left by that many units. So here e is added, so graph is shifted e units left. Graph of log x is basically shifted e units left. So that means at minus e we have vertical asymptote, and at a point which is 1 minus e we will have output as 0, and after that output will be positive. So the graph will be somewhat like this. This is the graph of log of x plus e. And now what about the next function? This function can also be written like this: 1 by y equal to e raised to x, which also means y equal to e raised to minus x. So it means it is a graph which is decreasing, you know that. But to understand the relative orientation, let us check at least one point. So basically I want to see if when I draw this graph, whether it is going to cut before y-axis or after y-axis, I want to see that. So for that I will check at what point this graph cuts y-axis. So if I put x equal to 0, I will get y as 1. So this point is basically 0 comma 1. And we know that this function also gives us 1 as output when x is equal to 0. So the graph of the second function also passes through this same point. So the graph will be somewhat like this. And we are interested in which area? We are interested in this complete area formed with x axis. So now also you can observe that this area is definitely bounded, because here if you notice definitely curves are not intersecting, but because this is an asymptote, entire area could be limited. So whenever there is an asymptote, area could be limited because of the nature of the asymptote. Okay. So now we want to find this entire shaded region, but when I was shading I took a break at y-axis. So basically we will split this into two parts and integrate. Okay. So how do we do that? From minus 1 by e to 1 minus e to 0 we will perform one integral, and from 0 to infinity we will perform another integral, because here one function is there, one function is present from minus 1 by e to 1 minus e to 0, and second function is present from 0 to infinity. So we need to separate the integration and perform it independently. Okay. So what will be the area here? Area can be written as 1 minus e to 0. What is the function? Here I am using the blue function, which is log of x plus e plus dx plus integral 0 to infinity e power minus x dx. Okay. So, if we just perform this, we can complete the integral. Also, you can do the integration with respect to y also. If you are doing it as area formed with y axis, then you can take the one function minus other function idea and solve it. Okay. So, that way also you can complete it, but that is left to you. I am asking you to explore that at home, but here I am using only the area formed with x axis. Now, how do we further proceed? For that we need to integrate this function. Okay. So, here I am basically integrating log of x plus e. Okay. Now, what do we do when there is log? We of course use the integration by parts. So, here I will do a very a simple smart idea. When I integrate 1, I generally get x and into log of x plus e minus, we keep this function x here and differentiate log of x plus e and then integrate again, right. This is our method. But when I am integrating 1, I can get x, I can get x plus any constant also. So, what I will do is I will take e here. Okay, so, that is my smart move. I have taken extra e here just to make sure that when I am differentiating log of x plus e, my e gets cancelled. That is the main reason why I put e here. Now, it is just an integration constant. So, at the end answer should not change because of this. Okay. So, this x plus e will get cancelled and what am I left with? X plus e into log of x plus e minus what is the integral of 1, it can be taken as x or x plus constant, it does not matter because when we put limits anyways constant get cancelled. So, now we have to just substitute limits in this. So, x plus e into ln of x plus e and limits going from 1 minus e to 0 minus x, again limits going from 1 minus e to 0, and integral of e power minus x is very simple integral. It is minus of e power minus x, limit going from 0 to infinity. Now, when I simplify, what do I get? When I put 1 minus e here, so e gets cancelled, I will get 1, but here it becomes 0. So, first value is 0, and next when I put 0 here, so I will get e into ln e, which is 1, and next minus when I put 0, I will get 0 here minus 1 minus e, and here when I put infinity, e power minus infinity becomes 0 minus e power 0 becomes 1. Now, when I simplify, what am I getting? Just see, minus e here and minus into minus plus here. So, plus 1 minus e and plus 1, right. There must be some kind of mistake here. Okay, so, there must be some kind of error here, some simplification error. So, you must be getting the value here to be 2 only. Okay, so, just check if you are getting the value 2 or not. Okay. So, basically here if you observe, what have we done here? We have basically taken the area using the graph and then we integrated two functions separately and then we got the answer. Okay. But one smart move that we did was, while integrating, when we are integrating 1, we took directly x plus e instead of x, so that it becomes simple. Okay. So, can we proceed now? Okay. So, please make a note of this. Okay. Can we proceed? So, here the actual mistake was we put the limits in reverse order. So, it must be plus e and e must have got cancelled and you will get 2 as the answer. Okay. So, this is how we will solve this problem. So, I hope you are liking these techniques. So, in every question, whenever we are solving any question, during the process, maybe for 5 seconds or 10 seconds, the ideas like these may pop up. So, this happens only through our discussion with you and me. With this discussion only it can happen. So, that means listening to every solution is also very important. Even though you are able to solve the question, even though you could solve the question, you have the ability, but still there are some very minor but very important ideas which will enhance your speed. So that is why you need to attend and go through every step of every lecture. Okay. Now we will go to the next question. So next question is, find the positive value of B for which the area between these two curves is maximum. So how do we do that? Again, we draw the graph first and then we observe the area. Based on our observation, we go for the formula of area using the integration. Once if we get an expression for the area, then we try to maximize it, right? We have to maximize it. So how do we do? Let's start with the graph first. Now when I factorize this, I am getting factors like one is x, other is 1 minus bx. Because b is positive here, the coefficient of x square is negative. So it is going to be a downward parabola. It's a downward parabola. And what are the roots? The roots are going to be, one root is 0, the other root is 1 by b. These are the roots. This is my first function. What about the second function? It is simple upward parabola. So which will be somewhat like this. Now what is the area that is enclosed between these two? This is the area. So now to find this area, we have to of course solve for the points of intersection. One point of intersection is already clear, which is the 0, 0. That means we got the lower limit as 0 and we need to find the upper limit. So let's say I take the upper limit as p. So that means we have to integrate the function from 0 to p. So 0 to p, this is going to be my area. What is the upper curve? Upper curve is the first curve, which is x minus bx square minus, what is the lower curve? Lower curve is the y equal to x square by b curve. So x square by b into dx. This is going to give me the area. But we need to find value of p. So let us solve these two directly. So x minus bx square is equal to x square by b. Now further, there is one factor which is already common, which is x. So we have already catered for that root. So I am cancelling x here. So what will I be left with? 1 minus bx equal to x by b. So x is coming out to be 1 by b plus 1 by b. I will name this as p. Now let us integrate this. So while integrating, out of these two, x square can be taken common. We can observe that. So when I integrate the first term x, so I will get x square by 2, limits going from 0 to p, minus when I take b plus 1 by b common and integrate x square, the integral will be x cube by 3, limit going from 0 to p. Now when I put p here, we will get p square by 2 minus, this term is actually 1 by p, because here if we observe, 1 by p is basically b plus 1 by b. So here we can write 1 by p into p cube by 3, and luckily p is getting cancelled, and what is left? P square by 2 minus p square by 3. So this becomes p square by 6. Now p has the parameter b. We have to now maximize this entire area. But if you look at the expression for p, what is the expression for p? It starts with b plus 1 by b. But we already know that in the question it is mentioned that we are looking for the positive values of b. So definitely we can assume that b must be positive value. That is how I have drawn the graph also. If b was negative, then this must be a reverse parabola. These two parabolas must get reversed if b is negative. Okay. So I have assumed b to be positive from the initial steps only. So that means here by applying AMGM inequality, we can say that b plus 1 by b by 2 is greater than equal to root of b into 1 by b. So this will give me b plus 1 by b belonging to 2 to infinity. Now what happens when I take reciprocal of this? 1 by b plus 1 by b will be belonging to 0 to 1 by 2. That means p is belonging to this What about p square? P square will be belonging to 0 to 1 by 4. So here we notice that the maximum value of p square is 1 by 4. So that means area which is p square by 6 is definitely less than equal to 1 by 6 into 1 by 4, which is 1 by 24. So the maximum value of area is 1 by 24. Now that maximum occurs when p is at its maximum, which is 1 by 2. So when p is at its maximum, b must be at its minimum, or sorry, b plus 1 by b must be at its minimum. B plus 1 by b is minimum when b is equal to 1. That is when AMGM inequality is satisfied with equality. So in AMGM, equality occurs when all terms involved are equal. So b must be equal to 1 by b, which will give us b equal to 1. So basically at b equal to 1, area is maximum. So that means we have found the value of b. Okay. So this way we can solve this problem. Come on, make a note of this. This page also. Okay. So with this we close all the problems that we wanted to discuss in the last lecture. Now let us go to the technique of drawing graphs. So we can name it as curve sketching technique. And here there is an algorithm that I have developed. You will not find this technique in any book. It's my technique. And this is based on my observations. Also, if you practice more questions and gain some experience, based on your experience, you can also design some techniques. You can modify this technique, you can add more points or subtract points. That is left to you. I am basically laying down a path for you to walk on, but it's you who has to walk the path, not me. Okay. So here, what do we do when we encounter any function which is random function? If the function is of the standard functions, we know how to handle them because graphs are standard, we already know all the graphs. But what if a function is mixture, if it is confusing, if it is random, how do we handle? We follow these techniques. Now what are these steps? First step is to check the symmetry. Now how do we define symmetry? If you have notebook, you better write down the points that I am discussing. So there is one kind of symmetry which is symmetry about y-axis. If any graph is symmetric about y-axis, then what happens is when I replace x with minus x, the algebra must remain same. In the equation given, in place of x, if I put minus x, equation must not change. Then that means graph is symmetric about y-axis. Similarly, if I replace y with minus y and if the equation remains same, graph is symmetric about x-axis. Okay. So of course I am going to take more examples on this in the subsequent problem solving session. And also there could be other type of symmetry. Suppose if I swap x and y, that means interchange x and y, and if the equation remains same, that also means that the graph is symmetric about y equal to x line. These are the basic ideas you might have learned already. Okay. So that is the symmetry check. Whenever we look at any function, we look for the symmetry. Now which functions to be checked for symmetry? If there are even powers, if there is modulus sign involved, if there are trigonometry or exponential terms, then you may look for the symmetry. Okay. Next, roots and not defined values. So we try to solve, if possible, we try to get the roots and not defined values either by substitution or by solving. Okay. Now after that we put the signs. What are these signs? You have learned the wavy curve method. In wavy curve method, while solving inequations, we used to find some intervals and we used to put signs based on the simple qualitative analysis of signs. So these are the signs that I am talking about. And after these steps are completed, then we go for the asymptotes. Now in asymptotes, there could be three types of asymptotes. One is the vertical asymptote, horizontal and slant asymptote. Now vertical asymptotes can be understood in two ways. One is, there are some standard functions where vertical asymptotes naturally exist. For example, log x graph has y-axis as the asymptote. We have also seen one example here in the earlier example. See, log of x plus e has one vertical asymptote. Okay. So, these are the standard asymptotes which are naturally in the function. For example, if we take tan of tan theta or tan x, that also has many vertical asymptotes. Cot, sec, cosec, these functions also have natural vertical asymptotes. That is one way, that is the natural existence of vertical asymptotes. There is also another way. So, vertical asymptotes can be split into two ideas. One is the natural asymptotes that we have just discussed now. The other could be due to the existence of the 1 by 0 form. That means by substituting any value, if the output becomes 1 by 0, I am not talking about 0 by 0, I am talking about only 1 by 0. 0 by 0 will not give you asymptote, but 1 by 0 will give you asymptote. Okay, so this is one hit point which you have to remember, that if there exists any situation of 1 by 0 or any constant by 0, but constant must be non-zero value, then vertical asymptotes are possible. Also, the other case could be limit x tending to any constant, the output must be going to either plus infinity or minus infinity. Basically, that is exactly what I am talking about here. When we hit 1 by 0 form, basically we are hitting a value like this. Okay. So, here vertical asymptotes exist. What about horizontal asymptotes? To understand horizontal asymptotes, we need to understand this idea that limit x tending to either plus infinity or minus infinity, if f of x is tending to a constant, then that means the entire function is going to tend to a constant at the extreme values, either right extreme or the left extreme. At these two extremes, the output is going to tend to a constant. So, that is the horizontal asymptotes. And next is the slant asymptotes. Slant asymptotes occur when numerator is effectively 1 degree higher than the denominator. Remember, numerator is 1 degree higher than the denominator. In such cases, slant asymptotes exist. So, basically here what happens is, limit x tending to infinity or minus infinity, f dash of x will tend to a constant, and that constant is basically the slope of the asymptote. So, this I have discussed when I was discussing asymptotes in hyperbola. You can also revise that step once before you go for any slant asymptotes. Okay. Next, there is one simple point here. When we are talking about slant asymptotes, we are basically checking if the curve is tending to a line or not as x tends to infinity or minus infinity, right. So, here if horizontal asymptotes exist, then slant will not exist. If horizontal exists, then slant will not exist. If horizontal does not exist, there is no guarantee that slant will exist. Okay. So, that means when horizontal asymptotes do not exist, slant asymptotes may or may not exist. That may change depending on the situation. Okay. I have taken one example of slant asymptotes also in today's lecture. And after these asymptotes are drawn, we can go for the study of the derivative. So, basically we differentiate the function and we check the critical points. What are the critical points? Critical points are the points where derivative is either 0 or not defined, that is it. If derivative is 0 or not defined, those are critical points. So, here when derivative is 0, it means that tangent is parallel to x axis, that means curve probably is taking a turn or something. And when derivative is not defined, it means tangent is parallel to y axis, right. That is one of the ways. If it is differentiable and derivative does not exist, then tangent is parallel to y axis. Otherwise, it could also be the differentiability test, but here we are not getting into such micro level. Next, If derivative is positive, that means graph is increasing, derivative negative means graph is decreasing. Okay. So, with these 5 steps, we get lot of data, about the curve, and then using that data we will try to draw the graph using common sense. 6th step is the most important step because common sense is not so common. Okay. Now, studying the derivative, understanding derivative 0 and derivative being positive and negative, this is cakewalk for all of you, because most of you have practiced very well in applications of derivatives. So, the questions that I am designing are not actually based on this 5th step, are actually based on these only 4 steps. So, that means today I will take maximum examples which cover only these 4 steps, not the 5th step. 5th step is minimized today intentionally just to suit your practice. Okay. So, now can we move on to further steps? So, basically whenever we are drawing any function of any graph of any function, then basically we will do these steps in a systematic manner. That is it. Can we start one question now? Let us say this is one function. So, I have taken one simple function, this is a rational function. Rational function means ratio of polynomials. So, you might have seen such functions in your functions chapter. In fact, if you notice, I am slightly tangentially moving out of the track, because the main track is area under curve, but I am tangentially going out to explain you these techniques, and then after a while I will fall back to the current chapter. Okay. So, because we have not touched the applications of derivatives or the functions chapter, because those are the 11th chapters, I am covering this here so that there is a skill for you. Okay. So, now how do we start with this? First step is symmetry check. Put x equal to minus x and see if the equation is same or not. Basically, f of x is equal to y here. So, when I put x equal to minus x, there is no symmetry because equation changes. When I put y equal to minus y, equation changes, no symmetry. If I swap x and y, then also equation changes. So, y equal to x symmetry is not there. Generally, if symmetry is there, you will see it directly. You will get the gut feeling from inside. Okay. So, symmetry we checked. Okay. So, I will just remove this. Symmetry we have checked. Now, let us check roots and not defined values. So, when I factorize this, what are the roots that I am getting? When I factorize this, so I am getting y equal to x minus 3 into x plus 2 divided by x into x minus 4. So, this is my second step. I got 3 and minus 2 as the roots. These are the roots, and 0, 4, 0 and 4 are the not defined values. So, I have got the second step. Now, I have to put signs. To put the signs, I have to plot these numbers on number line, right. So, let me just draw one x axis here. So, let us say that this is my x axis. Okay. So, I have drawn very big x axis here because we have to explain the entire process. Now, what are the not defined values? 0 and 4 are the not defined values. So, let us take 0 here and 4 here. What are the roots? 3 and minus 2. So, there is one root here 3 and there is one root here which is minus 2, right. Next, what is the next step? Signs. Because here the coefficient of x in every factor is positive, and also every factor has odd powers. So, how do we start? Rightmost is plus sign. Every factor has odd powers, so sign will change alternatingly. So, these are the sign changes. Now, let us go back. So, now we are going for the asymptotes. So, first let us check for the vertical asymptotes. Now, this is not a standard function which will give us vertical asymptotes, because we already know all standard functions which have vertical asymptotes. So, then we go for the next check. What is it? Next check is the not defined values. So, if I put 0 here, numerator is not 0, but denominator vanishes. So, 1 by 0 form is coming. If I put 4, same story. So 0 and 4 must be vertical asymptotes. So that means at 0 we have one vertical asymptote which is same as y axis, and at 4 also we have one vertical asymptote, right. So we got the vertical asymptotes. Now let us go for the horizontal asymptotes. To get the horizontal asymptotes, we need to find out limit x tending to infinity, what happens to the output. So x square minus x minus 6 by x square minus 4x. So how do we evaluate these limits? You already know, you are already master in these techniques. We have to divide with x square. So we get 1 minus 1 by x minus 6 by x square divided by 1 minus 4 by x. Now as x tends to infinity, this 1 by x, 6 by x square, 4 by x, all these terms will tend to 0. So we will get the output to be 1. So similarly, as x tends to minus infinity, the output also will tend to 1 because it is the same limit. Okay. So this means y equal to 1 is one horizontal asymptote. Okay. So because horizontal asymptote is existing, slant asymptote will not exist. Now coming to this. So what does this mean? It means I am just drawing the line y equal to 1 here. This is my y equal to 1 line. So this means as x tends to infinity, that means here as x is tending to infinity, the value will tend to this asymptote. And similarly, as x tends to minus infinity, the curve will approach this asymptote. But what about the middle? In middle, curve may cut the asymptote or it may not cut, that depends on the situation. But only at the extremes, the curve will approach the horizontal asymptote. Okay. So we have done horizontal asymptote, slant asymptote does not exist here. Now I am not doing this, I am not doing the derivative test. Okay. So now using this information, I am going to draw the graph directly. So how do we do that? Let us start from the basics. What is the meaning of plus sign here? It means output is positive, which means graph is above x axis. Minus sign means graph is below x axis. So now let us just observe beside 4. In the just right side of 4, we have plus sign and there is this asymptote here. There is hole also here. What does the hole indicate? At exactly 4 value is not defined. So there must not be any point here. But just in the right side of 4, value is plus positive. That means the value must start from, graph must start from plus infinity like this. Okay. So I will just draw this in red so that there is no confusion. So it must start from plus infinity, that means graph must be somewhat like this. Okay. Now what about this part? Graph is starting from plus infinity, right. Now throughout this region, value is only positive, that means graph cannot cut x axis. So this must be tending to this line, because horizontal asymptote says that the curve must tend to the curve, curve must tend to the line. This is the idea. But there could be a slight confusion here, which means the graph could also come down and approach the asymptote from below. We do not know which is the correct case. We will see, we will check which is correct little later. But there is this possibility that either this curve is cutting the asymptote and approaching it from below, or it is approaching from above. Both are possible. We will deal with it little later. Now I am going to the left side of 4. In the left side of 4 there is minus sign. So that means graph must start from minus infinity. And at 3, because 3 is a root of the function, at 3 there must be a cut on x axis. So the graph must cut x axis here, and then see in the region which is between 0 and 3, the value is positive, and at 0 there must be an asymptote. So graph must start from here and it has to somehow converge here. Okay. So, this will be the graph here. Now, what about the left side of 0? Again graph has to start from minus infinity. At 2 there is a root, so graph will cut x axis and then graph will approach y equal to 1 line either from below or from above. One of these two are possible. Now, how do we verify out of these two which one is correct? We will just do it shortly. But before that, if you notice, we have almost completed the graph just by using these ideas. Okay. So, now how to check whether the above graph is right or below graph is right? For that, what we do is we take the function, we equate it to the output and check, because we have observed that y equal to 1 is the asymptote and we want to see if the graph is cutting this asymptote or not. So, for that what we do is we basically equate this function to 1 and solve it. So, now when I solve it, what do I get? So, here x square is getting cancelled and if I take 4x to this side, 4x minus x, it becomes 6. So, which means 3x is 6. So, which means x is equal to 2. That means there is a cut. If there exist solutions here, that means graph is cutting horizontal asymptote at one point and that value is x equal to 2. Now, let us observe where is this x equal to 2. It must be somewhere between 0 and 3. So, basically this cut must be 2. Okay. So, my graph is little shifted this way, but that is fine. Okay. So, our algebra clarified that graph cuts horizontal asymptote at only one value, which is x equal to 2, which means above 4 there is no cut. So, that means which part is right? The graph is approaching the line from above. Similarly, here also there should not be any cut below minus 2. So, graph is approaching the line from below. So, this way we can confirm our doubts and we can proceed. Now, let us say there is no way you can solve the algebra. Let us say if the function is not a simple polynomial function, let us say the function is not simple polynomial function and let us say you are not able to solve it, then you just leave it, okay, that is fine. But what we are interested in is basically the simple graphs. Okay. So, basically this is one technique of drawing graphs of rational functions. So, here I have taught you how to deal with a rational function, but we can also extend this idea to any function. Okay. Come on, make a note of this and then we will take another example. Okay. Now, can we move on to the next function? So, here there is a rational function and there is one exponential function and we want to take the product of these two functions. So, this is the function given. We can still draw the graph of this function. How do we do that? We break this analysis into two different functions. So, first I will take this function which is x square minus 1 by x plus 2. First I will take this function and then I will take this function y equal to e raised to x and then I will analyze both of them separately. So, first if I factorize this, I will get x minus 1 into x plus 1 divided by x plus 2. So, how will this graph look like? Okay, so 1 minus 1 and minus 2. So, let us say this is my y axis. There is one root which is 1, there is another root which is minus 1 and there is one not defined value which is minus 2. So, that means at minus 2 there must be vertical asymptote and signs, look at all coefficients of x, all are positive. So, rightmost is plus, all factors have odd powers. So, sign must change alternatingly, right. Next, that is it. Is there any vertical asymptote? We have taken care of that. Is there any horizontal asymptote? So, look at this, there is one thumb rule. If degree of numerator is let us say p and degree of denominator is, let's say, q. If p is equal to q, then horizontal asymptote exists. Okay. If p is less than q, that means numerator has lesser degree than denominator. I am talking about only ratio of polynomials. So, if p is less than q, that means denominator has higher degree. So, then in that case x axis is horizontal asymptote. X axis is the only horizontal asymptote. Now, if p is greater than q, then there may be two cases. If p is equal to q plus 1, then there is slant asymptote. If p is still greater than q plus 1, then no slant asymptote also. Okay. So, that means function may increase rapidly. Okay. So, this is the idea. Now, using these ideas we can draw the graph. Here if you notice, numerator, degree of numerator is exactly 1 unit higher than the degree of denominator. So, slant asymptote may exist. Slant asymptote means function may tend to a line. Okay. As x tends to infinity and minus infinity, function may tend to a line. So, here how will the graph behave? I will draw that in blue, because this is the vertical asymptote. So, here the graph will start somewhat like this. It has to cut at minus 1 because it is a root. It has to cut at 1 because it is a root. So, graph will turn and go this way, and here the graph may approach one straight line. Okay. So, that straight line you can calculate directly by looking at this also. So, because here if you observe, if you write this function as x minus 1 by x by 1 plus 2 by x. So, as x tends to infinity, y is tending to x. This means y equal to x plus constant will be our asymptote. See, we without even finding the derivative we could get the slope of the curve. Okay. So, here to find the constant c, we have to subtract x from here and see what happens to the limit. Okay. So, that I am just doing as a rough work. So, limit x tending to infinity, the function which is x square minus 1 by x plus 2, from here I am subtracting x, and let us see what happens. So, it becomes limit x tending to infinity, x square minus 1 minus x square minus 2x divided by x plus 2. So, x square is getting cancelled and this is giving me a limit of minus 2. So, y equal to x minus 2 is an asymptote. So, where is the line y equal to x minus 2? It will be somewhere here. This is the y equal to x minus 2 line. Okay. So, this left side it may cause a little trouble to you. So, I will bend this line little bit like this. Okay. So, now this means this graph is going to tend to this line. Okay. So, ideally it must be like this. So, the board is not sufficient here to explain this. So, let us say that the line is like this. Let us say that the line is like this. So, the graph will tend to this line. Okay. Similarly, here in the left side you can observe that because at minus 2 there is vertical asymptote. So, it has to start from minus infinity and it will approach this line. Okay. Now, this graph looks very similar to this graph. If you have observed this function x plus 1 by x function, okay, the graph looks like this. This is the y equal to x line which acts as its asymptote. The graph goes like this, and this maximum value comes at minus 1 and this value is minus 2. This minimum value comes at 1 and that value is 2. We have seen these values using AMGM inequality, but here I am explaining you using the graph. Okay. So, just like this the graph also behaves here. Okay. So, I hope you have understood this idea. Okay. So, now just to complete it, I will just change this nature. Okay. So basically we are assuming that the graph is somewhat like this, okay. This is the graph of the first function. Now of course I can understand that we are taking time, but we are also learning new techniques, so be positive about it. Okay, next. Now let us look at this second function, y is equal to e power x. How will this function behave? This function is very standard function which behaves like this, okay. Now we want to draw the graph of the combined function, that is the product of these two. So here if you notice, e power x function is always a positive function. Now when we are taking the product of two functions, of course this is positive, this is also positive. So in this interval the net result is positive. In this interval one is negative, one is positive, net result is negative. So similarly we can analyze the signs for every interval, okay. So here I will draw the graph of the final function. If you like this graph, you can also take a snapshot of this, okay. So basically we have one x-axis here, and what are the roots here? 1, -1 and -2 is the not defined value, okay. And here we have observed that all the signs of the original function are same as this function also, because second function is always positive. If second function changes signs, then appropriately we have to put the signs. Now coming to this, the rightmost we can say that it is tending to infinity because both are increasing, and here one is tending to infinity but the other is finite, it must be a constant here. So the result will be tending to plus infinity here. So that means we can say that the overall graph may look somewhat like this. At -2 there is a vertical asymptote, and at -1 it has to cross x-axis, and after 1 it has to increase very rapidly because both are increasing, hence the product also will increase very fast. What about the value here? Here if you observe, there is one minimum value for the blue function, and this function if you observe, what is the value here? It is 1. So when we take the product of these two, this minimum value will only become the overall minimum also. So here that will be the overall minimum value, okay. Now again coming to the left side. So here because there is a vertical asymptote, graph must start from -infinity. But what about here? As x tends to -infinity, graph will tend to 0, overall output will tend to 0 or some other value, will depend on whether e power x is dominating or whether this function is dominating. So out of these two functions, which is the dominating function? So here if you take the first function, effectively it is a linear function and e power x is exponential function. When exponential function is compared with any other functions in our 11th and 12th standard, exponential function dominates. So that means here the overall output must be tending to whichever is the value that e power x tends. So overall value will be tending to 0. So as x tends to -infinity, this value will tend to 0. So here you have also observed that there could be cases where in the left side horizontal asymptote exists, but in the right side it does not exist due to the mixture of multiple different types of functions, okay. So this way we can draw the graphs of different functions. I hope you have liked this technique, okay. Come on, make a note of this also. Just wait, keep note down. Okay, so next one and also this page. So here main idea is to take different functions and how to handle it. When there is a product of two functions, how to handle the graph. When there is a rational function, how to handle the graph. Now let us go to solve some problems of area under curve. So we have tangentially moved out, we have learned some techniques, and then we are falling back. Let's say we want to solve this question. We can solve this question in two ways. We can blindly solve it, we can also go for graphs and solve it. So first I will explain you how to solve it blindly, and then I will explain you how to solve it using graphs. Probably in today's lecture we may not be going for graphs, we will at least solve it using algebra, and then in the beginning of the next lecture I will explain you how to solve it using graphs. So we want to find the area bounded between these two curves. Now this is the other approach that many students use, so hence I am discussing once. So this is without graphs, without drawing any graph. So in the question it is given that area is bounded by these two functions only. So that means if I solve these two functions directly, if I get points of intersections, area must be bounded between only those two values. So I will try to solve them directly. Now when I equate both and try to solve it, what do I get? I get an expression like this, equation like this. So here definitely log x is common and other will be ex whole square minus 1 equal to 0. So log x equal to 0 will give us x equal to 1 and the next factor will give us x equal to 1 by e and minus 1 by e. Because log x is not defined for negative values, so minus 1 by e is not in the domain only, so it is straight away rejected. So we got two values here which are 1 and 1 by e. Out of these two, which is smaller value, 1 by e is smaller value. So I can straight away take the area as integral going from 1 by e to 1, take one function minus the other function. We don't know which function is above and which function is below geometrically, but we can put a modulus sign outside. Okay. So that means I can straight away take it as ex into log x dx minus 1 by e to 1 log x by ex into dx. I will first evaluate this value and based on whatever value that I got, whether it is positive or negative, based on that I will put the appropriate sign. Okay. So then how do we proceed? You know how to integrate this. So integral of x log x will be basically x square by 2 into log x minus, again we have to differentiate log x, that becomes 1 by x. So it becomes x square by 4, limits going from 1 by e to 1 minus, what about this? Because 1 by x is derivative of log x, so we can write it as 1 by e into log of x whole square by 2, limits going from 1 by e to 1. Let us simplify these two. So e into, when I put 1 here, so this becomes 0 and this becomes minus 1 by 4 minus, when I put 1 by e, so it becomes minus of 1 here and there is 1 by 2 e square here. So we will get 1 by 2 e square and there is because of minus sign, so we will put plus there. And similarly this also will become plus and 1 by, it becomes 4 e square. Okay. And similarly the next one, let us simplify the next one, minus 1 by e into, of course 1 by 2 is also there. So when I put 1 it becomes 0, so 0 minus, when I put 1 by e it becomes minus 1, minus 1 whole square is 1 only. Okay. Now let us simplify this further. So what are we getting here? So just let me check if everything we have done is right or not. So when I put 1 here it becomes minus 1 by 4, that is fine. So it becomes minus e by 4 plus 1 by 2e plus 1 by 4e, right, plus 1 by 2e okay. So now you see if we can cancel out terms, so nothing is getting cancelled. But if you check overall value, is it going to be positive or negative? So depending on the value whether it is positive or negative, you can put the sign. Okay. So just simplify it and further check if it is possible or not. Okay. So okay. So this way we can integrate, but we actually don't know if the function is lying above or below. We don't know what is the orientation of the curves. We don't know whether function is continuous or not between these two intervals. because we straight away integrated from 1 by e to 1, we don't know whether function is continuous or not. So for all these things, it is always better to have a graphical idea. But I will discuss the graphs in the next lecture, and then I will explain you how to use the earlier techniques in these graphs also. So there are two ways of solving problems. When there is a problem, you can straight away hit it with algebra, provided there is one logical support of your algebraical steps. If there is no logical support, then you may have to take help from the graphs. Even otherwise, you may have natural curiosity of graphs. Maybe in some questions, you may have to find the minimum and maximum values. There you need again graph. Or maybe sometimes you may have to find how many cuts are there, how many number of roots are possible. So in such cases, you need to know the graph. So that is why I have taught the graph drawing technique. You can use that technique and practice at least 5 to 10 questions before coming to the next lecture. In the next lecture, every problem that I will solve, I will explain using algebra, and also I will try to explain using the graphs. Okay. So I think I will stop today. I will stop here today. We will meet again in the next lecture with more problem solving skills. Until then, have a great learning day. Learning shall never stop.